Hello students, this is part 2 of lesson U2A01. In the past video we derived the quadratic formula. So what we're going to do in this video is we are going to talk about the graph of the quadratic equation. So we're going to we're going to talk about the graph of the quadratic formula. So the graph of the quadratic formula, okay, is actually known as the parabola. And there's actually a very involved discussion of like why it's called a parabola, and then like different ways of like defining what a parabola is, and many different applications of this. We'll save that for another time. But the graph of a parabola, or the graph of the quadratic equation, is not formula. What am I saying? The graph of the quadratic equation. The graph of the quadratic equation is known as a parabola. And having gone through Algebra 1, having gone through, the geometry course, okay, we should have an understanding of the general shape of what the parabola is. So generally, the parabola will look something like this. It looks almost like a U shape. Okay, now a parabola can be right set up in this manner, or can certainly be upside down, depending upon what the situation is with the values that are presented. So the equation, again, the quadratic equation, looks like this. So again, depending upon what the A, B, and C values are, okay, it can actually alter the way that the parabola looks. We'll save that for another time, but for the main focus here is we're going to try to graph any parabola that is presented to you. So one of the key features, okay, whenever we're trying to analyze something, okay, we look for patterns, okay, and that's what separates a person that is good in math and then a person that, that struggles in math. If you want to get better in mathematics, okay, you should always look for patterns, okay, and not try to memorize things. So what we have here, okay, is a graph that looks symmetrical, right? This is one of the key features, okay, behind what a parabola is. A parabola has an axis of symmetry. And the axis of symmetry, okay, is exactly in the middle. And parabolas, okay, may cross the x-axis either twice, once, or none, okay? So the values for r, so r here is the roots, otherwise known as the x-intercepts. And there is actually a possibility for there to be 2, 1, or 0 roots. Okay, so we can have 2 roots, 1 root, or no root, depending upon where the parabola is situated. Every parabola will have a y-intercept, and so what we're going to try to do now is we are going to try to look for ways in which we can, get the different values from a quadratic equation when presented to us. So in the last video, we developed this really important formula, which was the quadratic formula. And let me just reiterate that. It was x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. So this quadratic formula allows us to figure out what the roots are. So this, and if you look at this, okay, and actually I should say that this is actually going to give us root 1 and root 2. It's going to give us root 1 and root 2. So why is it going to give us root 1 and root 2? Well, that's because if you look at the quadratic formula, we actually have 2 operations in here. So one of the root, so let's just spell it out, right? One of the root 1, will be negative b plus square root of b squared minus 4ac. over 2a, and then the second root will be the same exact thing. However, the operation in between is not going to be addition, but rather it's going to be subtraction. So we end up with that. So we have two roots. And if you look at this, okay, if you look at what's happening here, okay, and I'm going to place this over here so that you can see it a little better, right? So I have the sky. I want to move this so that's over here. And I want to move this so that's over here. And I want to get rid of this so that there's less stuff on the screen. So now let's check this out, right? Root 1 and then root 2, right, is this guy right here. And then root 1 is this guy over here. So let's just take a moment, right? If I wanted to figure out what is the equation for the axis of symmetry, and the axis of symmetry being that it's a vertical line, it should be x equal to some quantity, right? Being that it's exactly symmetrical, this point right here, okay, will be the midpoint between R1 and R2. So what I can do is, okay, I can take R1, I'm going to use another color, so I can take R1 plus R2 divided by 2, and what I will get is going to be that middle point, that midpoint. And that midpoint is going to be my axis of symmetry. So that's exactly what I'm going to do then. What I'm going to do is I'm going to take these two things, okay? I'm going to take this. Actually, I'm going to take this. And I'm going to take this. And I'm going to add them together. I'm going to add them together. And then divide by 2. And this will give me my midpoint. So what's going to happen if I do that? Boy, you're looking at this and you're probably wondering, like, I don't know, Mr. Chan, are you going in the right direction here? Well, you know, don't be afraid of large, complicated-looking fractions just because they're all just numbers, and all numbers look and behave the same exact way. So what happens is, to make this clearer for everyone, I'm going to break this up into two fractions here, right? So the transition looks like this. So I have 2a and then 2a, where this side over here, this was plus, and then this is 2a, and this is minus, and I have 2a. If you look at this closely now, right, I'm trying to find the average, one more time, I'm trying to find the average of the two roots, because if I do that, I'll end up with the axis of symmetry. This will give me the axis of symmetry. So if I do that, find the average of these two things, okay, notice now, these two quantities are positive and negative of one another. So they'll cancel out. What am I going to be left with? I will be left with negative b, I will be left with negative b over 2a plus negative b over 2a, all divided by 2. And last I checked, if I'm adding two fractions with the same denominator, I'm just adding the numerators then. I have negative b over 2a, all divided by 2. And if I'm dividing fractions, I'll end up with, well, I have the 2 and 2, that makes negative b over a, all divided by 2. And if I'm dividing fractions, I'm actually multiplying by the reciprocal. So what I end up with is negative b over 2a. And this is going to be the axes of symmetry formula. And the axis symmetry, just keep this in mind, it's a vertical line. And the way in which we write the equation for a vertical line is x equals. Okay? So this right here is the formula for the axis of symmetry. So we have actually two different formulas now that we can work with. One more time, we have the axis of symmetry formula, and then we have, which gives us the middle axes, and then the other formula that we have is the quadratic formula, which gives us, again, the roots. And one more time, even though we're writing x there, just understand that these are R1 and R2. Okay? These are the values for R1 and R2. All right?